Hello my dear children, welcome to the mathematics class. Today we are going to discuss limits and derivatives. In this chapter we are going to discuss the sums in the exercise 13.1, page number 302 in the textbook. We have already completed 22 questions so far in this exercise. Okay my children, now see the question number 23. Question number 23. Are you ready to listen the class, my dear children? Right. See here. Find as x tends to 0 limit of f of x and as x tends to 1 limit of f of x, where f of x is equal to 2x plus 3 when x is less than or equal to 0. 3 f of x is equal to 3 of x plus 1 when x is greater than 0. Okay my dear children, if you observe this function here, f of x is defined in two different ways. When x is less than or equal to 0, then f of x is equal to x plus 3. When x is greater than 0, then f of x is defined as 3 of x plus 1. Okay my dear children, in this case f is said to be piecewise defined function. Okay my dear children, what is f of x called here? Piecewise defined function. I will write that word. Okay my dear children, here the function f is called piecewise defined function. Okay my dear children, right. Now come to the given data. What is given here? F of x is equal to 2x plus 3 when x is less than or equal to 0, 3 of x plus 1 when x is greater than 0. Okay my dear children, so this function is defined in two ways. So I will represent this function on the number line. To understand this function well, at what point the function is defined in two different ways? At 0, isn't it or not my dear children? See here at 0, 1, 2, okay, this is the number line. At x is equal to 0, so at this point left side is defined as f of x is equal to left side, isn't it or not my children? Right. Now f of x is equal to, if x is greater than 0, the values more than 0, the values of x are more than 0, then f of x is defined as 3 of x plus 1. Understood this diagram my children? Understood this figure? I have drawn number line. At this point 0, the function is defined in two different ways. So I have drawn a line, dividing line at x is equal to 0. Left side is defined as f of x is equal to x plus 3 and the right side of 0 is defined as f of x is equal to 3 of x plus 1. Understood this point my children? Right. Now we have to find limit of f of x as x is approaching to 0. So at this point we have to find limit of f of x. So in this case we have to find left hand limit and right hand limit. At this particular point they have asked limit, isn't it or not my children? So we have to find two types of limits. Those are left hand limit and right hand limit. I wrote in the short form LHL stands for left hand limit. RHL stands for right hand limit. So at this point we are finding left hand limit and right hand limit. Okay, my children, please listen these points carefully, my children. Right. So as extends to 0 minus limit of f of x is equal to, as extends to 0 minus denotes left hand limit of f of x at x is equal to 0. This is the notation, symbolic form of left hand limit of f of x as extends to 0 from left. Okay, my children, understood? Right. So is equal to, as extends to 0, here extends to 0 minus means left hand, the value is less than 0. How the function is defined? F of x is equal to 2x plus 3. So we have to consider this function only, not this function. Don't consider this part. Left hand limit means this function only. Okay, my children. So we have to write 2x plus 3. Understood this step, my children? And moreover, here no need to 0 minus. Just to write 0 only. Because we have decided, we have found the actual function. That is why you no need to write as extends to 0 minus. It is enough to write as extends to 0. Understood this step, my children? I wrote, see the difference between these two steps. Here I wrote as extends to 0 minus limit of f of x, means left hand limit of f of x as extends to 0 from left. But here I wrote as extends to 0 only, not 0 minus. Understood, my children? Because we have found the exact function. What is f of x? Here 2x plus 3. Not this one. We should not consider this function in this case. Understood this point, my children? Right. Now we substitute. We go to substitution method. That is equal to 2 of 0 plus 3. Here x is approaching to 0. So in this function we substitute x is equal to 0. Understood this point, my children? Right. 2 into 0 plus 3. Understood this step, my children? Now let us simplify these values. What do you get? 2 zeros are 0 plus 3. So what do you get? What is the left hand limit of f of x as extends to 0? 3. Now come to RHL. We denote symbolically as extends to 0 plus limit of f of x. Left hand limit means 0 minus, here 0 plus. Understood the difference, my children? Right. We follow the same steps here also. We have to find out 0 plus means x greater than 0. If x is greater than 0, how the function f is defined? This one only, not this one. So we have to consider this one only. Okay, my children. So in this step, we write as extends to 0. No need to write 0 plus. Okay, my children. Same steps. We follow the same steps here. 3 of x plus 1. Because we have found the exact function. 3 of x plus 1. Understood this step, my children? Right. Now we substitute. After finding what we have done here, substitution method. Here also we have to go to substitution method. So 3 of 0 plus 1. Because as extends to 0. So we have to substitute x is equal to 0 in this function. Then we get to this step. Understood this step, my children? Right. That is equal to 3 of, what will you get? 3. Understood this is step, my children? So what is left hand limit? 3. What is right hand limit? 3. Both are equal. Here left hand limit. Here left hand limit is equal to, both are equal. Both are same. Here also we got 3. Here also we got limit is 3. Therefore left hand limit is equal to right hand limit. Therefore we say that as extends to 0, limit of f of x is equal to this number only. Limit of f of x as extends to 0 is equal to 3. Understood, my dear children? Right. So this is the first part of the question. As x tends to 0, limit of f of x is equal to 3. We have found. Similarly, they asked we have to find as x tends to 1, limit of f of x. So we are finding the limit of f of x as x tends to 1, as x is approaching to 1. Okay, my children, see here, as x is approaching to 1 means, as x is approaching to 1 means x greater than 0, isn't it, or not, my children? Here x is approaching to 1 means it is greater than 0, so we have to consider this function only. No need to find left hand limit and right hand limit of f of x at x is equal to 1. Okay, my children, because at 0 only f is defined in two different ways, but at x is equal to 1 directly we can consider this function as x tends to 1 means x is greater than 0 or not. Yes, so we have to consider this only. No need to find here left hand limit and right hand limit of f of x. Understood this point, my children? Right. Therefore, as x tends to 1, limit of f of x is equal to, as x tends to 1, limit of, what is f of x here? As x is greater than 0. At x is equal to 1 means x greater than 0. Therefore, we have to consider this function only. 3 of x plus 1. X tends to 1 means x greater than 0. Because of this reason, we have considered this function only directly. No need to take this one. No need to find left hand limit and right hand limit of f of x at x is equal to 1. Understood this point, my children? Is it clear? Right. Now we substitution method. That is equal to 3 of 0 plus 1. What you will get to 3 of 1. So this is the limit of f of x as x is approaching to 1. Understood this point, my children? Right. Come to the question number 24. Next question. Find as x tends to 1 limit of f of x where f of x is equal to x square minus 1 when x is less than or equal to 1. F of x is equal to minus x square minus 1 when x is greater than 1. If you observe this function, here also the function is defined in two different intervals. If x is less than or equal to 1, f of x is defined as x square minus 1. If x is greater than 1, f of x is defined as minus x square minus 1. So the function f is called here a piecewise defined function. Okay, my children, because the function is defined in two different intervals, in two different ways. That is why f is called piecewise defined function. Okay, my children, right? Understood this point? Right. Now come to the solution part. What is given? F of x is equal to x square minus 1 comma when x is less than or equal to 1, and f of x is equal to minus x square minus 1 when x is greater than 1. Like this the function f is defined. Now I will draw a number line. So on this number line, at which point the function f is defined in two different ways at x is equal to 1. Understood this point, my children? So at x is equal to 1. At x is equal to 1, the function is defined in two different ways. Left side is defined some other way and right side is defined some other way. So f of x is equal to x is less than or equal to 1 means left side of 1. F of x is defined as x square minus 1. Understood this point, my children? Right. Now right side, x greater than 1. X greater than 1 means right side of 1. F of x is defined as minus x square minus 1. Understood this point, my children? Understood this figure? Right. Now we find left hand limit and right hand limit of f of x as x is approaching to 1. Okay, my children. At this particular point, we have to find the limit of f of x. So, in this case, we have to find left hand limit and the right hand limit of f of x. Understood this point, my children? As we have done for the previous question number 23, we follow the same steps here also. Left hand limit. So I am finding here left hand limit. This side I am finding right hand limit. So symbolically we write it as extends to 1 minus f of x. Understood this is symbolic form, my dear children. Left hand limit of f of x as extends to 1 means 1 minus. We have to write it symbolically like this. Okay, my dear children. After that we have to identify the exact function of f of x. X tends to 1 minus means left side. How the function f of x is defined? X square minus 1. So we have to consider this function only. Okay, my children. So as x tends to 1, limit of x square minus 1. Here we need not consider this function here. Understood this point, my children? Understood this step? Right. Now we go to substitution method. Understood this point, my children? So 1 square minus 1. What will you get? 0. 1 square value is 1 minus 1. 1 minus 1, 0. So left hand limit of f of x is 0. Okay, my children. Now come to the RHL, right hand limit. How do you write symbolically? As extends to 1 plus, as extends to 1 plus limit of f of x. Okay, my children. Understood this is symbolic form. Right hand limit of f of x as extends to 1 plus is equal to, as extends to 1, limit as extends to 1 plus means x is greater than 1. So we have to consider this one only. For x values are greater than 1, we have to consider this function, not this function. So minus of x square minus 1. Understood this step, my children? Why we have considered this one in this case? Okay, my children. Now we substitution method. So minus of 1 square minus 1. What will get? Minus 1 minus 1. What is right hand limit here? Minus 2. What is left hand limit here? 0. Are these two limits equal? Not. They are not equal. Here left hand limit is not equal to right hand limit. In the previous question we got both limits are same, but in this case we are not getting the same value. Left hand limit is different from right hand limit. They are not equal. So we wrote this step. LHL is not equal to RHL. Understood this step, my children? Right. Therefore, we say that as extends to 1, limit f of x does not exist. Finally, we say that as extends to 1, limit of f of x does not exist because both limits are not equal. Understood this point, my children? Right. Now come to the next question, that is question number 25. Question number 25. Evaluate limit of f of x as x is approaching to 0, where f of x is equal to mod x by x, comma, x is not equal to 0. When x is not equal to 0, f of x is defined as mod x by x. And f of x is equal to 0 when x is equal to 0. Okay, my children, understood this question? Right. Now come to the solution part. What is given? We wrote that function f of x is equal to modulus of x by x when x is not equal to 0, and f of x is equal to 0 when x is equal to 0. Okay, my children. Here the function is modulus function. The combination of modulus function f of x is defined with the combination of modulus x. So we rewrite this function. Because at x is equal to 0, it is defined. Okay, my children. As you know, modulus of x is equal to x when x is greater than 0, and modulus of x is equal to minus x when x is less than 0. Do you remember this absolute value function, my children? Definition of absolute value function. This is also called modulus function. So we use this previous knowledge to rewrite the given function. Okay, my children? Right. So when x is less than 0, we have to write. When x is greater than 0, we have to write. Okay, my children? Right. Let us rewrite the given function. Therefore, f of x is equal to, when x is less than 0, then mod x value is minus x. So minus x by x. X less than 0, minus x by x. What will you get? Minus 1. Okay, my children, understood this point? So minus 1. F of x value is minus 1. And when x is equal to 0, f of x value is 0 only. When x is greater than 0, mod x value is x. When x is greater than 0, mod x value is x only. So x by x. Understood this step, my children? Right. That is equal to, after simplification, x by x. What will you get here? 1. So 1. When x is greater than 0. Like this, we have to rewrite the given function. Understood this part, my children? Now we have to find the limit of f of x as x tends to 0. Means left hand limit, and we have to find the right hand limit. Okay, my children? As x tends to 0, we have to find the left hand limit and the right hand limit also. Understood this point, my children? Right. So we rewrote the given function f of x. So therefore f of x is equal to minus 1 when x is less than 0. F of x is equal to 0 when x is equal to 0, and f of x is equal to 1 when x is greater than 0. Okay, my children? We rewrote the given function like this. Okay, my children? Now the function f is called piecewise defined function, because in different intervals f is defined in different ways. Okay, my children? Now I represent this function on the number line. See here 0, here 1, 2, 3, 4, left side minus 1, minus 2, minus 3. So at x is equal to 1, f of x is 0. At x is equal to 0, f of x value is 0. Left side, what is f of x here? Minus 1. Understood this point, my children? What is the right hand side of 0? F of x is defined 1. By using these results, I am representing the function on the number line. Understood this point, my children? Now we have to find left hand limit and right hand limit of f of x at x is equal to 0. Okay, my children, left hand limit. So we are finding left hand limit and right hand limit of f of x at x is equal to 0. Okay, my children. So symbolically we write as extend to 0 minus. Do you remember this part, my children? How to write left hand limit of f of x as extends to 0? Symbolically, this is symbolical form. Okay, my children. Right. As extends to 0, limit of left hand limit means left side 0. How the function f is defined? F of x is equal to -1. So we consider the function only -1 only. As we have proceeded for the previous question, we follow the same steps here also. Understood this step, my children? Right. Now we substitution method. Here we put x is equal to 0. Is there x value? X is there in this function? No. So -1 only. So the limit of this function as extends to 0 minus is -1. Understood this left hand limit, my children? Right. Now come to right hand limit. As extends to 0 plus limit of f of x as extends to 0 plus symbolic form of right hand limit of f of x as extends to 0. Okay, my children? Right. So here we write as extends to 0, limit of 0 plus means right hand side of 0. How the function f is defined? F of x is equal to 1. We have to take this function only 1. Understood this step, my children? Right. That is equal to, we go to substitution method. Here x is approaching to 0. So we have to substitute x is equal to 0. But here x is not there. So this only, constant, that constant only. Understood this step, my children? So we got here left hand limit is -1 and right hand limit is +1. Both are not same. Therefore, left hand limit is not equal to right hand limit. Understood this step, my children? Both are not same. That is why we wrote this step. Okay, my children? Therefore, as extends to 0, limit of f of x, what do you say? Does not exist. Does not exist. We say that the limit of f of x as x is approaching to 0 does not exist. Understood this question, my children? Right. Please try the remaining questions in this exercise, my dear children. Okay, will you try yourself the remaining questions in this exercise? Right. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children? Understood? Right.